In films and books, one of the ways to tell if the character is rich is if they have gold. In today's Lord Gizmo video, we will look at how this symbol of wealth is acquired and processed. We will also take a look at its other uses other than jewelry. The first step has to do with the mining phase, or extracting the gold. It is not found directly on the Earth's surface in large quantities, so most of the mining processes involve taking a deeper look at the Earth's crust. Gold can be extracted using two different main types of extraction. It can either be through surface mining or underground mining. When resources or minerals are found close to the surface mining is employed, using explosives and heavy gear to remove waste rock and reveal the gold-bearing ore. This approach entails extracting gold from a big, open pit. When the ore is easily accessible and the gold deposit is near the surface, open pit mining is frequently employed. In comparison to underground mining, this technique can be less expensive and enables for large-scale mining. If appropriate safeguards are not followed, it can also seriously harm the ecosystem. Conversely, underground mining is usually employed in regions with challenging geology or when the gold resource is situated far below the surface. Compared to open pit mining, this technique can be more costly and calls for specialist equipment. Since the gold is removed from the entire vein rather than just the surface layers, it can also lead to higher gold recoveries. When compared to open pit mining, underground mining can also lower the danger of environmental harm. When resources or minerals are found far below the surface, underground mining is employed. Although this form of mining is more costly and risky than surface mining, it is essential for gaining access to some of the most precious minerals and commodities. Gold extraction from deep underground mines is a multi-step process. Getting the mined ore to the surface for additional processing is one of the first and most important steps in the process. Large dump trucks or other heavy machinery, made especially for maneuvering the treacherous mine environment, are usually needed for this activity. These sturdy vehicles transport the ore-holding gold from the mine's depths to the processing plant. This facility's location may change based on distance and logistical considerations. It may be positioned near the mine, but in other situations it may be farther away, necessitating careful preparation for transportation. The world's deepest underground gold mine is South Africa's Mponeng mine, extending over 4 kilometers, about 2.5 miles, below the Earth's surface. This depth surpasses the height of most mountains. At such depths, temperatures can soar up to 60 degrees Celsius or 140 degrees Fahrenheit, creating a sweltering work environment. To combat this, a unique ice slurry is used to cool the air, turning this subterranean world into a paradox of fiery rock faces and icy breezes. The processing facility puts the gold ore through a number of stages in order to extract the precious metal. The ore is fed into specialized machinery in the first stage of crushing, which reduces it into ever tinier pieces. This procedure, which is essential for separating the gold from the nearby rock and minerals, makes use of enormous crushers that can handle hard, huge materials. Grinding, which follows after crushing, further grinds the ore particles into an even finer powder. Large spinning mills loaded with steel rods or balls for grinding are usually used to accomplish this. After that, the fine powder moves on to the next phase of processing, where it undergoes a chemical treatment meant to dissolve and extract the gold from the leftover undesirable elements. It is not enough that the rocks are just placed inside a grinding machine. There is still a lot of process that goes after that to truly extract the gold. Cyanidation is one of the processes this batch of rocks must go through. It is utilizing a mild cyanide solution, usually sodium cyanide, to dissolve the gold. Gold and cyanide combine to generate a soluble complex that makes it possible to separate the metal from the remaining ore. Its affordability and efficiency make it a popular choice. However, some nations have outlawed its use due to environmental concerns. They will then need to experience heap leaching. Using this technique, crushed ore is stacked on a pad that has been specially made and then sprayed with cyanide solution. After dissolving in the mixture and seeping through the heap, the gold is gathered and processed. When the ore's gold content is too low to make more conventional processes like flotation and milling economically viable, this technique is frequently employed. Refinement is the last stage of the process that the gold particles go through after they are effectively separated from the leftover rock and minerals. The goal of this important step is to further purify the gold by getting rid of any leftover impurities and reaching a higher purity level, which is frequently greater than 99.5%. The two most used processes for refining gold are smelting and fire assay. Fire assay comes first. The precise measurement of the material's gold content is the main goal of this technique. It entails heating the gold-bearing substance to a high temperature in a furnace. In order to expedite the melting process and isolate the gold from undesirable constituents, fluxes and a reducing agent are added. The gold is carefully separated and weighed to ascertain its exact quantity after it has been completely melted. Smelting places more emphasis on physically removing the gold from any residual impurities than fire assay does. This process melts the gold-bearing material by using intense heat, usually above 1064 degrees Celsius in a furnace. Fluxes are essential in this process because they help generate slag, a waste product that contains the impurities. The slag, which is lighter than the molten metal combination, rises to the surface and is gently skimmed off as the mixture heats. The remaining pure molten gold is then poured into molds to harden into the required shapes, such as ingots, which are then ready for trading or further use. The mine's once rough gold is refined into a very valuable commodity through these painstaking steps, making it suitable for a wide range of uses in many sectors and applications. Despite being associated with jewelry and riches, gold is an essential aspect of modern technologies, especially circuitry and electronics. For applications requiring effective current flow, its remarkable conductivity, resistance to corrosion, and ductility make it the perfect choice. Consistent performance and signal integrity are guaranteed by gold's resistance to tarnishing and corrosion, especially in delicate electronic components, because of its ductility and malleability. It can be formed into complex shapes and pulled into thin wires, which makes it ideal for tiny circuits and sensitive electronic components. Thanks for watching our video all about mining gold. We hope you learned something new and interesting about this fascinating process. Please do not forget to give this video a thumbs up and subscribe to our channel for more.